and pulling in game data. Okay, next up, what do we need to do? We probably want to start actually getting something onto the screen, and I'm thinking that can be the grid, because the grid is going to be central to everything. We're going to have a grid, and it's going to store all of our game objects and put everything inside of there. So let's create our grid next. So add in a marker, create grid. Okay, so next up, creating the grid. Let's go ahead and create a new, well, actually, you know what? I keep on forgetting to do this before I change anything. You're all good. Pulling in game data and push that up. If you just joined us recently, you can follow along with this code at Bang Repo. Okay, we want the grid. Let's go ahead and close all these windows up, start nice and fresh. I want a grid out of here. Grid.rs. Mod grid. All right, so let's create this. Pub struct grid. Okay, so what are we gonna do here? We want to know what the size of like each cell is. So we're gonna want like the cell width and the cell height. So these are gonna be F32s. I'm gonna want to be able to like draw the grid out. So like draw each cell, which will be like a rectangle. So we could store that. So let's create the like a cell mesh, and that should be a mesh. Graphics mesh. And then we're going to want like the cells itself. So this is going to be interesting. Our cells, I want this to be like just a representation of our entire world, as it were. So I'm thinking a vector down and a vector across. So we're going to have a vec, and this is going to be the y's, right? So it's going to be a vec y down. So it's going to be a vector of vectors. And then the vector vect, this one is probably going to be a hash map. So the equivalent of like a dictionary in Python or an object in JavaScript. So let's go ahead and bring in that type. It's not brought in automatically for us, unfortunately. A hash map, and then its types. So I'm thinking everything is going to have an ID. It's like when we create anything to go in here, we're going to have an ID, and that can be, I mean, it depends upon how many items we're going to have in the world at the same time. So let's just do a U64. That should be plenty of like ID size for us to deal with. And then the item of like what's going to go in here. So we need a game object that goes in here. So let's go ahead and create a game object. And then in-game object, we're going to need a pub and that's just so that I can pull that in and store that in here. Okay, so we have our cells, we have our cell width, our cell height, And then a cell mesh for us to draw each cell out so we can like verify that it's working correctly. I don't think we're going to care about like a background for this. We're just going to make it, you know, the grid should be invisible. Only the things inside the grid should be displayable. And so with that, I think we're good to sort of get going with this. Let's go ahead and implement for the grid. All right, so cell width. So we actually know that this is coming in from our game data, don't we? We're gonna have the cell size. Our cell mesh will take care of ourselves, but in order to create the mesh, we're gonna need a context. It's not in graphics. Okay, so context, and then the cells, we're just going to create an empty set of these to begin with. So that's going to be fine. So then we're going to return our grid. Okay, so most of this is going to be simple. So like grid, we'll do cell width. The cell mesh is going to be interesting. So we need to create that here. Which means we need a mesh builder. We also need a rect. Okay, and we're gonna need our draw params and everything else. But I guess we'll bring those in as we need them. So, all right, mesh builder, new. Let's do a dot rectangle. So I'm thinking just like a standard rectangle grid, and I'm only gonna do the outline of it. So the stroke instead of a fill. So a mode, so we need the draw mode. Okay, a stroke, and our width of this, I think we can just say this will be like a 1.0 size. The bounds, this is gonna be a new rect. And this is gonna be just basically the location of where it is. So I'm thinking I'm gonna start this in the top. So I can either do like the center of it and then just like move everything up as a square around it, or I can do the top left and then have the square go from there. It really depends upon how I'm planning on like seeing that the mesh work. Do I want, the grid, the cells to work? Do I want the cells to like be in the center of them or like in that top left of it? I don't know. I don't know if there's a correct answer to this. We just have to be consistent. So let's just do like the top left because that's how almost everything in like drawing to the screen works. So in our X, we'll do 0.0, 0.0, our cell width, and cell height. And then our color. I want this probably just a plain white. So I can actually bring in that constant. Okay, we have our bounds, that's a rect. And I think I can just build it now. Pass it into context. We do want to question mark this, and we're good to go. Now we have to return a game result. So then you should be happy there. And then the game result, we're going to return okay. Okay, like you. Okay, and so we're missing this actual mesh here. So we'll do the cell mesh, and then the cells. So the cells are not too terribly hard to build for us, but cells equals. So outside vec, there's a macro for us to like create a vector really easily. It's just like that. So it's a vector, that's the outside vec. The inside vec is repeat that. And then the hash map, so let's create a new hash map. And it will figure out what it needs, what the type needs to be as soon as we put it in here. So we can see this is like vec unknown. As soon as I put you in here, it's like, okay, I know, it's a vec of hash map. Got it. So then all that's complaining about is that we're not using this. So let's go ahead and store the grid in the main library here. Now, what does our grid take? Let's go ahead and our grid is going to take in cell width, cell height, and then the context. So we don't have that in here right now. So we need to pass in the context. Now, if we're doing the context, we're going to have a game result return from here with the game state. So wrap you around that, and that should be happier, except now we're missing the grid. So let's go ahead and add that in. All right, so cell width. So we can hand in game data. I think dot cell size. And then the context and question mark here. Now it's yelling at us saying, hey, these are private. We don't have access to this. So in game data, let's go make cell size public. All right, so what's next? It's now saying, hey, you moved the value. So like this error again, right? We gave ownership of game state here to game data. So either I can clone it, or we do this grid ahead of time up here. Just take you, move you up there. Semicolon, and then we don't need you. So we're going to grab the cell size out of it, and then we're going to move it in, give ownership to the game state at this point. So the order of things matters in Rust. All right, so it's just yelling at us that we're not using some things. But now we have some errors. Function takes 2 arguments. So game state here, when we create it, it also takes in the context. Okay, but now it, let's see, the trait bound results, let's see, where is that? Oh, because this is returning a result, so we have to handle this now too. So let's go ahead and match, match this. If it's an okay, we're gonna grab the and we're going to return that game state. if it's an error, we're going to take in the error, and then we're going to, I guess, panic and pass in error loading game state, pass in the error there. There it goes. And now we have the game state that we can pass in properly. No errors, just a bunch of warnings. We've written a lot of code without running it. Let's go ahead and run this, see what happens. We still don't have anything printed to the screen, but we can get there pretty soon. So, I mean, we've created the grid and we're storing it away. So let's go ahead into our grid and let's actually create a draw method here. So let's see, pub function draw. We're gonna need context so that it can draw itself. All right, and we'll turn a game result here. So here's what we want to do. We want to call graphics draw for every single cell. And get that going. The problem is we don't have any cells, do we? So that's a problem. Let's actually, when we create this, here's all these cells. Let's go ahead and push them in. So we're going to create a for loop here for this. So for, so it's like the standard variable. So this is going to be our y count. And do I even care about like what this is? I don't know. We'll figure it out. So y count in 0 ... exclusive from cell height. So y count is going to be a number. Now this is a F32, so that's kind of sucky here. Let's convert this into a U32. And then we're going to do the exact same thing for the x's. Then I want to just push an empty hash map into each of these cells. So I guess here we're going to create our new vector. So if we start with our cells as just an empty vector for this, we want this to be mutable so we can start updating this. For every single y, we're going to have a new row. So like that. Then for every x, I want to put in a hash map inside of there. And that's pretty much it. We're just going to push in an empty hash map. Not the best use of memory, but I think it works for this. Now for this row, at the end of each one of these, we want to push that into cells. So now it figures out what that is, and we store them in here. So now in here, we can loop through all of the rows and then draw out our rectangles and place the rectangle, place this mesh in the appropriate spot, and redraw it. So a single mesh copied all over the place. All right, so let's go through our y's. So for this is gonna be the y, essentially index. Well, the way that it works is similar to Python. or like a for in loop. We're actually going to get the row in here. Now that being said, I actually do need the index to do some math to like move each of the cells over into the appropriate spot. So I do need the y index, and then the actual row too. So let's do this. We're going to get the y index, and then also we're going to get the full row in self.cells. I need to turn this into an iterator, and then from there I can enumerate, and that gives me this index and the actual row. So that's going to be this reference to a vector. References are fine here. I don't actually need, I'm not mutating them, so we're okay. And then we're going to loop through all of the x's in here too. So for the same exact thing, we're going to do x index, and then this is going to be the actual cell. So iter.enumerate. All right, so now I have the cell and the x index. We now need to draw our cell mesh in the appropriate spot. So what do we want to do? We want to do a graphics draw, pass it in the context, pass it in a reference to the drawable, so that's self.cellMesh, and then any draw params. So we need that now. All right, so draw params are going to be interesting. In our draw params, we can have dot, like a new destination for it. And that takes a point. So we need a point. All right, so for the x for this, we're going to take the x index and we're going to multiply it by the size, and that should move it over. So if it's like the 0, 1, so that top left, 0 times the size is 0, 1 times size is down by like however many that was. I think it's like 50 pixels or so. So what are you going to look like? You're going to say new, let's see. The x, that's going to be x index times your U size. We're going to need to convert this over to an F32 because that's what dest needs. But we'll do that at the very end of this. So we'll actually wrap this in parentheses. Okay, so x index times the cell size. So self.cell. This is going to be width as an F32. And then the other one, which is going to be the y index. And then that's my destination for this. Graphics, we're going to question mark that. Nope, not there. Here. Semicolon. And at the very end, we have to return OK. And that should make all of those disappear. All right, what are you upset about? Can you not find? Yeah, we don't have graphics in here. So you're yelling at me that y index is, oh right, because cell width is a F32. So we have to convert one of these over. I'm thinking that we want to convert these over to, I wonder instead of like as F32. Let's try this. As F32 here. Not have these parentheses. Let's see what happens. The math might be a little bit wrong, but this is just drawing the grid, and it's not like super important that it's like 100% accurate. All right, we're not using the cell. Okay, so we're gonna have draw here. Now we're gonna come back into library, and in draw, we're gonna do self.grid.draw, pass it in the context, and question mark the result. And there we go. No errors. Let's see if we have a grid. We do. We have a grid, and it is wonderful. So that's good. What happened? I somehow how did I like make everything go away? That wasn't cool. Like everything minimized on all my windows. Bring you all up again. Okay, so here we have our grid. It's displaying out. Perfect, perfect, perfect. And that's kind of it. We've created our grid. We're able to display it out. The grid does extend past what we've seen right here. So if I want to move around and actually see, like us moving, we're gonna need to deal with the, deal with the camera system for it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 things here. Is that correct? I think it is. But if we take a look at this, we do have a number of rows. So in our game data here, we have a world height. And we want this to be a U8. That's going to be the number of cells that we're allowed to have maximum, height-wise. Let's actually use this in our grid when we create. So not draw. When we create the new one, let's bring in our world height. This is a U8. Now, for Y count instead of cell height, we only want to go down based upon the cell height, but then the width can sort of extend out to the side. So this is going to be the world height. Do I even need to convert you? Where are we using Y count? We're not. We can just do that. And it can iterate over and like figure out the U8s, and that's going to be fine. So if I do this, that one little change. Error. This function takes 4 arguments. Okay, so we're not passing in the world height now. That's our next problem. So this is going to be the game data dot world height. Function world height is not public. Okay, so let's fix that. There we go. No more errors. And our grid now goes down to here, and we can see that this is, what did we decide? Our world height is 10. If I bring this down to like 3, that now affects our game. So we're now able to control what this grid looks like through that JSON file. So if we want to tweak things around, that's how we do that. It's actually a really cool system to sort of not have to make these changes in code, especially if you're going to have like a game designer work with you. They can then work in the JSON and not like have to deal with the Rust code. Let's put you back to 10. Now, a problem with this, maybe it's not a problem. It's sort of dependent upon how we feel. This size here, that's kind of, it's not necessarily too happy with us. If we want to make the size of our window be exactly equal to the size of our grid height here, based upon this 10, we have to have I believe it's 500, because we're saying our cell size is 50, we have 10 of them, that's 500. Now, unfortunately, is that unfortunate? Maybe we can deal with this. Let's go into main. So here's our game data. If I pull in this game data first, and I do this before creating the context in a window, I'll have access to it, which means I have access to that world height, or the camera height. And I could then, when I'm creating this context and the event loop, where is that? New dot build. So before I build here, I can do a dot. I think I can never remember if it's a window mode or a window setup. Let's try window mode first. We need a conf window mode. In fact, we can just go look this up in the documentation. It'll be fast. Let's look up window mode first. Yeah, okay, so here's our width and our height. And we can see set the default window size or screen resolution in true full screen mode. So it's dimensions that we want to set. So we do want a window mode. We're gonna create a window mode. I don't see any like new or anything. So we're just gonna be window mode straight up dimensions. Dimensions takes himself. So we have to create a window mode. So we have to build this up first. Like that. Let's see. A builder structure, reanimate. Oh, because I haven't set all of these things. Oh, there's a default. Did I miss a default? Oh, because there's a trait implementation of default. So I can actually skip you. Go window mode, : default, like that. And then I can go into dimensions and then give it our X and our Y. This function takes 2 arguments. So our X, our width, that's gonna be this, I want it to be equal to our camera. So our camera width and our camera height. And this is just going to yell at us that these are not public. So we're slowly using all these and making those warnings go away. So that sets that up. There's nothing else that we really need to do here. We build that out. We have no errors. It's a very subtle change, but we're a little bit wider, and less tall. And so our grid, if we check these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 down and exactly the number across that we want. Perfect. That's exactly what we needed here. So this is excellent. We have our grid. So I'm going to go ahead and let's close all these up. I don't think we need to do any more refactorings. We could make some of these warnings go away. We're going to need them later, but let's go ahead and like clean up. So save view. Field is never read. So I can just make these. If I make these underscores, they're not gonna care about that. So warn dead code is on by default. Yeah, I'm just not gonna worry about these right now. I could make them public, and I think I do need to make them public. Which that makes those warnings go away because it figures somebody else's problem now. Now, what are you yelling at me? You're yelling at me because player data is not public. So you need to go down to the player data and make you public. Okay, so Y count is not used. So in this case, I can put a underscore in front of it, and that makes the warning go away. X count is not used. Cell is not used, same exact thing. Game data is not used here. So this is in the main game state. Yeah, we haven't. We're using it over here, but we're not really using it here yet. So can't deal with anything but that at this time. That's literally the same error twice. Cool. I could just not store it. And then we'll store it as soon as we need it. There you go. No errors, no warnings. We could run the game and we still get our grid displaying. It's the correct size and everything is good and happy. Let's go ahead and save this all up to GitHub. We'll eventually turn off the display and that won't be a problem. So I'm gonna push that up. Again, if you came since I started and you wanna take a look at this code, I have that under Bang repo and you can go take a look to your heart's content. So it is 10:20, it's been another, it's been like almost 2 hours since I last took a break. So I'm gonna take another quick break, stretch, walk around. I don't know if I need more water, but definitely gonna, like 2 minutes or so. Not very long at all. So, I need to end marker. So that's the end create.